I'm Alex Brown, and I'd like to introduce you to the tie plate connection design tool. This tool allows you to properly coordinate a tie plate connection with the joist top chord, with the plate either tucked up under the top chord or across the top. It does this by analyzing the plate, weld, and joist member sizes, which allows you to fine-tune each one to get the capacity you need. Let's jump in. So the first thing to point out are the tabs across the top here. So there's two scenarios where you might be using a tie plate connection. One where the plate is tucked up under the horizontal legs of the joist top chord, so you can see that in the detail here. And then the other, a top tie plate, where it's actually on top of the joist, spanning across the chord gap there. And then within those two scenarios, there are these reference info tabs as well. So for plate under, there's some additional commentary. You can see a few additional details, some equations, just kind of explaining some of what goes into designing this connection and how we would fabricate the joist in order to accommodate it. And same for the top plate reference here. In this case, showing some different scenarios how that plate might be attached to the top of the top chord based on how large it is. And we'll get into that here in a little bit too. And then the final tab is the technical revisions, and this just shows the history of the tool itself. So going back to the tie plate under tab here, so this is the main tool for calculating what that capacity is going to be. And if we just work from top to bottom, you can see up top here, project, engineer, job number. All of these are optional fields that are just going to print on the final printout. So this is really just for you as the user, as the designer. If you're printing out these pages for your own calc packages or submittal or something, this would just help you to identify what project you're designing this for and where. And then this tool does support LRFD and ASD, so you can see that drop down here. And if I flip between them, the main change is going to be the equations in the background, which everything is listed out here, and then how that capacity is presented. So you can see 11.1 kips based on ASD, or using LRFD 16.7. And then the layout of the tool itself is similar between under and top. First, you're going to define the plate itself. So this is for both plates, and you can see from that detail, there's two plates, one on either side. So we're defining the size of an individual plate. And then the weld that is attaching it to the top chord angle size, and then the joist info as well. So minimum horizontal leg, minimum thickness, and this would just go into the joist design itself, so us as a joist supplier can supply it properly, meeting those requirements. And then everything gets summarized in this box here, the plate size, weld, joist requirements, and then the final capacity. And this note off on the left here, with the default scenario that the tool populates, the weld is controlling the connection capacity. So that's kind of the weak link of this entire connection. And if I wanted to increase my capacity, that's sort of where it's pointing me towards. That's what I need to increase. Jumping over to this top tie plate tab here, we can go through this quickly. Very similar layout, defining the plate, in this case just one plate, the weld, the joist info, any minimum dimensions, and then all of that gets summarized here. And you can see one difference is tie plate installation is case 1. And in that case, it's because our tie plate is 3 inches wide, but our top chord of the joist is 5 inches. So that's 2 inches of the minimum horizontal leg plus a 1-inch gap between the chords. So that's going to be perpendicular to the view that we see here. And then another 2 inches for the far side angle that would be present with this joist. So 2 plus 1 plus 2 is 5 inches, but we got a 3-inch tie plate width. And if we go to the reference info tab, you can see very clearly how that would be detailed here with the plate centered in that space. As the plate gets bigger, our tool does take into account case 2 or case 3. And then there's some additional commentary here, particularly for case 3, where you have 2 overhead welds in order to get that attaching to the toe of the top chord angle. But let's go ahead and jump into an example, and we'll go back to the tie plate under. So you can see here, weld is controlling the connection. And again, these are just default, somewhat arbitrary values, but it's a good starting point for us. Capacity 16.7 kips, and that top chord thickness, you can see 0.125 matches the weld size of 0.125 or 1/8 inch. So because the weld is controlling, let's get some more weld onto here. If I bump up that weld size to 0.188 or 3/16 inch, the top chord thickness was able to auto increase as well, because that's one of the available sizes for a 2-inch horizontal leg. And you can see my capacity increased quite a bit. We're now up to about 25 kips. But the plate is now controlling the connection capacity. So one thing I want to point out is in this info bubble alongside the minimum top chord thickness. And that last sentence there, it's often better to use a smaller weld that is longer than to penalize the top chord angle thickness of the entire joist. And yeah, that minimum thickness is going to apply to the angle of the entire top chord, the entire length of that joist, not just the area around the bearing and where the plates are. So there's certainly a question of economy if that joist thickness wants to be that smaller size, but because of this connection it has to be thicker. That could potentially add weight to the joist design, which is going to add weight to the project and add cost to the project. So something to keep in mind as you're kind of pulling the different levers of this tool trying to design your connection. So because the plate is controlling, let's go ahead and bump up that plate size. If we make it a little bit thicker, we'll go 0.375, 3/8 inch. And you can see the capacity is 25.1 kips, so it really didn't move the needle much. Now the weld is controlling again. This tool is giving you that transparency, that visibility on how that connection needs to come together, and also how we as a joist supplier can sort of help make that connection possible with the minimum thicknesses or dimensions of the joist itself. And again, I'll emphasize that these dimensions need to be put on the structural contract drawings or contract documents, certainly up front, so that we can bid it correctly, we can detail it correctly to make sure all that's coordinated and that you're getting the capacity you think you're getting out of this connection. Jumping into a second example for the top plate orientation. So you can see from the default values, capacity 16.7 kips, again it's a case 1. The weld is controlling this entire design, but let's say that we wanted to hit 24 kips of capacity. That's the axial load that we want to transfer through between these two joists. And I can actually punch that into the tool itself. So this show connection demand field, I can toggle that over to yes, and that adds this field here, where I can actually specify exactly what I'm looking for, and it'll just give me just kind of a quick visual reminder of whether I'm achieving it or not, shown here in the summary box. So this is no good because 24 kips is larger than the 16.7 that we're getting, so we need to increase this capacity somehow. And because the weld is controlling, that's probably where I should start. So let's go ahead and increase that weld size a little bit. So if we bump that up to 0.188 3/16, you can see I'm almost to my 24 kips here, but now my plate is controlling the connection, so I want to increase that a little bit as well. So if I were to bump that up, 0.375, now I'm at 25.1 kips, which is perfect. I'm exceeding my 24, weld is controlling again. So again, you can see that different interplay between the different variables, and really you're able to make an informed decision about how to design this connection. And that's the tie plate connection design tool. It's a great tool that takes the guesswork out of using tie plate connections with joists. Be sure to check out our knife plate connection tool for designing larger axial load transfers. And with that, happy specifying.